Okay, so here we shall explain about the mean, the variance, and the standard deviation of a random variable, mean, variance, and standard deviation. Okay, so first we should understand what is mean by the mean. Mean is also called the average value of a random variable, or it is also called the expectation value of the random variable. So that is defined as, suppose we have x as a random variable which can take some values like x1, then x2, then x3, then till xn. And so the probability of this random variable x, that is also, so corresponding to the value x1, the probability is p1. Then corresponding to the value x2, the probability is p2. And corresponding to the value x3 of the random variable, the probability is p3. And similarly, for the value x3, the corresponding probability is pn. Then the mean the mean of the random variable x, that is also denoted by mu, or it is also denoted as the expectation value of x, e of x, that is given as summation of I goes from 1 to sorry, there's something wrong here. Summation of I goes from 1 to n xi into pi. So therefore, the expectation value of the random variable x, that is also denoted by mu, that is equal to summation I goes from 1 to n xi into pi, that will be equal to x1 p1 plus x2 p2 plus x3 p3, and it goes on till xn pn. And then the next is, what is mean by variance. Variance of a random variable. So then, so the variance of a random variable, it is represented by variance of the random variable x, variance of x, that is written as sigma x square. It means what? It means variance is the square of the standard deviation. Variance is square of the standard deviation. Or we can say that the standard deviation, if you have to find, means this sigma x is the standard deviation of the random variable x. So this standard deviation can be also written as, it is the square root of the variance. It means the sigma x can be written as square root of the variance of x, where the variance of the random variable x, that is equal to the expectation value of the x square, means expectation value of the squares of the random squares of the values of this random variable x, expectation of the x square minus of expectation of x whole square. It means that the variance of the random variable x, that can be written as summation of I goes from, sorry, there is some mistake here. Summation of I goes from 1 to n xi square into pi minus it will be summation of I goes from 1 to n xi pi its whole square. So this one is called as the expectation value of x, as we have defined here. And this one means this this expectation value of x square, that is defined as summation of I goes from 1 to n xi square into pi. And the variance of x is, it means that it is expectation of the x square minus the expectation of x whole square. And the standard deviation of x, and the standard deviation of the random variable x, that is defined as sigma of x, that is equal to square root of the variance of x. So therefore the sigma of x can be written as square root of expectation of x square minus expectation of x whole square and square root of that whole thing. So we can understand these three concepts we can understand, which is the variance and standard deviation and the mean. So these three we can understand by using one suitable example. So suppose it is asked to find the variance of the number variance of the number that is obtained on a throw of an unbiased die of an unbiased die. So in a throw of a die, as we know, in one throw of a die, the numbers that can be obtained with, so those will be 1, 2, 3, 4, 5, and 6. And here and since it is unbiased die, so it means, so each outcome is equally likely. So each outcome should be is equally likely. Equally likely means their probabilities should be same. The probability of getting 1 should be same as the probability of getting 2, and that should be equal to that of 3 and that of 4. So all should have same probability, that is 1 by 6. So therefore the sample space of the sample space of this experiment, that is S, that would be the name of the random experiment. In this case is a throw of an unbiased die. This is the name of the random experiment in this case, and the sample space would be 1, 2, 3, 4, 5, and 6. So therefore here it is asked to find so let's say we ask to find the variance and mean and the standard deviation. Okay, all three. So here we have, it is asked to find the mean, variance, and standard deviation of the number that is obtained on this throw of an unbiased die. It means the number which is obtained, the numbers which are obtained, that is only the values of the random variable x. So therefore the random variable x in this case, it denotes the number obtained, the number that is obtained on the die, So therefore x can take values 1, then 2, 3, 4, 5, and 6. And for each outcome, we know that the probability, suppose of getting 3, suppose I tell the probability of getting 3, that should be same as the probability of getting 1, etc., etc. And that would be, each would be equal to 1 by 6. No. So therefore the probability of the random variable x, that would be also for each, it would be 1 by 6, 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 and 1 by 6. So this would be the required probability, means this whole thing would be your the required probability distribution of the random variable x, of the random variable x. So now we need to find the expectation value of the random variable x, and that would be the mean. Obviously, mean would be same as the expectation value. It is also represented as mu. So that would be summation of I goes from 1 to n xi pi. So here it would be, here we have got 6 values. So it would be 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 and so on till it would be 6 into 1 by 6. There are 6 outcomes and each are having the probability 1 by 6. So this would be 1 by 6 times 1 plus 2 plus 3 plus till 6. So it would be 1 by 6 into, and the sum of first 6 natural numbers, that is n into n plus 1 by 2. So it is 6 into 7 by 2. So this would be equal to 7 by 2. Or we can write, therefore the expectation value of x, or the mean of the random variable x, that would be equal to 7 by 2, or we can write 3.5. And similarly, we have to find the expectation value of x square. So that would be summation of I goes from 1 to n xi square into pi. So that would be, so we have to take the squares of this random variable. So the squares of these all values we have to take. So that would be 1 square 1, 2 square is 4, 3 square is 9, 4 square is 16, then 5 square is 25, 6 square is 36. So we have to take the squares of these values of the random variable. So that would be 1 into 1 by 6, and that would be 1 square, actually 2 square into 1 by 6 plus 3 square into 1 by 6 plus dot dot plus, it would be 6 square into 1 by 6. So that would be 1 by 6 times 1 square plus 2 square plus 3 square plus till 6 square. So that would be 1 by 6, and we know that the sum of the squares of first n natural numbers, that is given as n into n plus 1. I think you know 1 square plus 2 square plus 3 square plus till n square, that is given as n into n plus 1 into 2n plus 1 by 6. No, it was there in the sequences and series. So here n is 6, here n is equal to 6. So we can write it as 6 into 6 plus 1, that is 7, and 2 into 6, 2 6 are 12 plus 1, that is 13, divided by 6. So that would be 6 and 6 would get cancelled. So this would be 13 sevens and 91, 91 by 6. So therefore the expectation value of x square, that would be 91 by 6. I can write it as, yeah, we can keep it like this only. It is 91 by 6. 91 by 6, or we can write it as 15 6 90. So 15 whole 1 by 6 also we can write. So here the variance of the random variable x, that would be equal to expectation value of x square minus the expectation value of x. So that would be 91 by 6 minus 7 by 2. So that would be 6 is the LCM. So 91 minus 2 is 6, that is 21. So that would be 70 by 6, or we can write it as 2 3 are 6, 35. So it would be 35 by 35 by 3. So therefore the variance of x, that is equal to 35 by 3. And therefore, and so the standard deviation, standard deviation of the random variable x, that is sigma of x, that would be equal to square root of the variance of x. So that would be equal to square root of 35 by 3. So that would be approximately your so approximately it is so 35 by 3 is approximately 12 approximately square. Once again, So actually we have to find out the approximate value of square root of 35 by 3. So the standard deviation value is square root of 35 by 3 and the variance is 35 by 3 and the mean value is 7 by 2. So this is your final answer. Thank you.